Hello, my name is Liam Symes, and I'm an undergraduate student at UWE Bristol studying games technology. I will be presenting two projects in this video that are both a part of the Advanced Technologies module. The first project is based on using AI tools and what kind of games can you build with them. I decided to primarily test with ChatGPT 3.5 as it was free and it is a widespread AI model that is heavily used by the programming community. However, I also researched into other AI tools for this project, such as GitHub Copilot, as on the GitHub website they suggest that the AI assistant speeds up programming tasks by 55%. The second project focuses on image generation tools and how they can help game designers. For this project, I decided to research a variety of image generation tools, but I primarily focused on using a paired image model called Pix2Pix. For this project, I used Google Colab as it provides free computational resources. It also allows users to write and execute Python code through the browser without any installations, but more on this later. So, for the first project, the brief was to use AI tools to see what kind of game you could build. Therefore, I decided to examine the potential and viability of utilizing ChatGPT for game development. But what is ChatGPT? ChatGPT is a natural language processing chatbot driven by generative AI. This means that the AI can understand, interpret, and respond with human language, answering questions, providing information, or assist with tasks. The fact that it is generative means that it can use previous conversation to learn and conversate with the user, rather than just respond with predefined responses. Unfortunately, any information generated by ChatGPT cannot be fully relied on due to potential misinformation or outdated information. This is more apparent with the free version compared to the paid version as it runs off an older dataset. The aim of my project was to see how useful ChatGPT could be to someone that is new to programming or has a low knowledge of a certain game engine. A secondary aim was to see how many different common game mechanics I could get ChatGPT to create inside the Unity engine. The scientific process I took to this was to maintain simple language when prompting ChatGPT and only allowing for a maximum of 15 prompts to be used per game mechanic. If a game mechanic was functional at a base level of what you would expect from an early implementation, then the mechanic would not need to be worked on any further, as I just wanted to verify where ChatGPT struggles and where it excels. To begin, I stated to ChatGPT that I had just created a new 3D Unity project, and could it generate a third-person character that could walk around. It provided a step-by-step guide on how to achieve this, but the first step guided me to import a 3D model. So I asked it, where could I find 3D models with animations that work for Unity? I continued to question every small detail as if I had no idea what I was doing, and followed ChatGPT's responses. In this case, ChatGPT actually managed to fix the bug. The following images will show the character without its textures and the character with its textures after following the instructions from ChatGPT. I followed this same method for each mechanic, and here is everything that ChatGPT managed to program. I rated each mechanic out of 10 based on how many prompts it took to get functional and how well it actually functions. I also tracked the number of prompts it took to get each mechanic to a functional base level, up to a maximum of 15 prompts. This was to limit overspending time on a given mechanic and is representative of the likelihood that an online tutorial with human initiative would be more efficient than trying to get an AI to do the work. So here are the results. From the experiment, it indicates that a novice programmer could benefit from using a coding assistant such as ChatGPT, as there are mechanics that it can produce with basic functionality in 5 prompts or less. This also shows that for some basic prototypes, it could be faster to use ChatGPT than to watch a tutorial and program manually. However, the other set of results shows that the mechanics that require engine-specific or visual adjustments within the visual editor prove to be a problem for the AI. To improve the validity and accuracy of the results found in this project, it would be best to test ChatGPT multiple times and test if it can generate the mechanics any faster from slightly different set of prompts. The conclusion I came to from my findings was that a novice programmer could use ChatGPT as a basic educator and programming teacher. However, if an individual wants to become a higher level programmer, they should look to become less reliant on using ChatGPT and use it as an assistant in a specific manner, prompting it with programming keywords and providing it with the finer details of what you want and how you expect to go about it. So for the second project, the brief was questioning how image generation tools can improve the workflow for a game designer. The aims for my project were to test different image generation tools and techniques, and evaluate what would be the best to create higher definition anime style characters from a base pixelated version character. The use for this would be to upscale the pixelated characters and not have to hire an artist for in-depth character design. For example, in pixelated games such as Stardew Valley or Sea of Stars, where they use some of higher definition models or headshots of characters when there is a cutscene or conversation. I started off by researching into some image translation methods, but I will cover this later on. However, I came across some websites that utilize stable diffusion, such as Perchance and Desgo. I gathered a reference image which was a pixelated male blonde knight. I then used Desgo's image-to-image generator and experimented by using different prompts and found a point where I was getting good results. I then tried out the change strength modifier, which determines how strongly the original image, which was my reference image, should be altered. Here are the results. I then used Perchance's text-to-image generator and began typing in prompts that could make the result image look as similar as possible to the reference image. Here are some of the best results. This led me to concluding that where text-to-image provided great results, it struggles to maintain consistency between images, whereas image-to-image is more consistent. However, it still fails to keep all the images the same, even when using the same prompt and change strength. I went back to researching and found that Pix2Pix would be a good image translation method to use as paired datasets provide more consistent results than image translation methods that don't require paired data during training, such as CycleGang. I then found an anime character dataset and began creating some Python code within Google Colabs to pixelate all the images so that I had a set of paired images that I could train the Pix2Pix model with. I struggled with the initial structure of setting up Pix2Pix due to the nature of what is required with the folder path structure and the naming conventions. However, I managed to save the base images and pixelized images directly into the correct folder format using my pixelation code repository. After this, I was ready to implement my paired images into a Pix2Pix model in a separate Google Colab. I did a number of tests by collecting the test image results based on different amounts the Pix2Pix model had been trained. For example, I did a test with 25-25 epoch and one with 200-200 epoch. For context, an epoch refers to a singular, complete pass through the entire dataset. So training for more epoch allows the model to see data multiple times to ideally improve its performance. Here are the results. In conclusion, I don't think the Pix2Pix model is the best model to use for upscaling pixel art characters to a higher resolution, anime style. The reason for this is how long it takes to train and to get the dataset is not worth it for what results you get. Especially as the results from the stable diffusion models using the image to image and the text to image models provide amazing results, as shown previously. To wrap up, Pix to Pix is definitely outdated, and a more contemporary method would definitely be useful for this kind of project. However, the creators of Pix to Pix have worked on Pix to Pix Turbo and other software, so this was definitely something to look into. Thank you for watching.